So I could spend the next hour describing to you how much of a pain in the ass this has been to put together, or you could take my word for it and just believe me when I say I've spent the last day or two trying to figure out shadow catchers and projections and all this, and without further ado, this is going to be the tutorial for how to put 3D objects in a VR kind of 360 degree scene. So before we start, I just want to make a quick note. So we're going to be talking a lot about shadow catchers and stuff like this, and this isn't like a normal kind of shadow catcher with a normal projection. No. The coordinate system that we're going to be using is wacky, okay? So just expect a bit of math here. I'm going to streamline a lot of this process, but to get this working in a 360 degree sense, where at any point you can like move around the camera, or we can even use like a normal perspective shot so it actually looks like it's on the ground, it takes a lot of work. And again, we're going to have a shadow catcher, so it's seamless. That being said, let's begin. Let's do a tutorial. So lately I've been messing around with a lot of 360 video and images and stuff like this, because again, I want to do VFX in 360, which means we need to put objects in 360. Well, how do we do this? Well, first thing we do with all of these, and I already mentioned this in the last tutorial, you always want to put your camera in the middle, okay? You want to think of the 360 degree VR environment or video or whatever it might be as kind of a sphere surrounding the camera, where the camera is in the middle. And this is basically our viewer, okay? So to load in our 360 degree nonsense, I'm gonna this time do it in the world shader. In the last tutorial, I made a sphere and you could project it on a sphere. Essentially the same thing, there's tiny differences, but I'll go over both here. World shader, where we are going fucking hell. We are going to add in a 360 degree environment. In my case, I'm just going to do an image, although if you have 360 degree video, that's fine as well. So here's just like a random HDRI I found from HDRI Haven, okay? It's in the world shader, it's in 360, and more importantly, when we look at the camera, we only get a small section of this. And like we talked about last time, again, you don't need to go back and watch it, but just so you know, we can change focal length, and we can also change the direction that the camera's facing to kind of look around this VR scene. So these are our VR goggles, okay? With that being said, how do we now set up our objects in Shadow Catcher? Well, first thing we need to do is we need to put down a ground plane, right? Just like any other scene. I'm going to make a ground plane. I'm going to make it like 3 times as big. And assuming that this 360 degree photo is captured from a tripod, I guess this should be under the camera, right? So the camera's on a tripod and it's above it. Now, one thing you need to immediately understand about 360 degree workflow, unless you're doing camera tracking or something like this, we do not really have control over knowing exactly where objects are unless you take on-set measurements. But the advantage, even though that's a downside, the advantage is no matter where we put it, it's going to stick to our footage. So you can see this plane looks like it's actually part of our footage. If I position it here and say this is the ground plane, this also, whoops, you want to rotate the camera, but point is this also works. So no matter where you put this ground plane, it's fine, which is a plus and a minus, because again, we don't know where the ground plane should be. So I'm just going to estimate that the ground plane should be here, and let me make it a couple times bigger. Next thing I'm going to do is I'm going to put down an object, whether it be a monkey or a Taurus. Weather. Love it that I did that. You just want to position your object in a 3D space. It could be, again, anything you want it to be, and I'm just going to position it so it's like in one direction of this VR environment, so you have to look this way to see it. So again, go to your camera view, make sure you have your camera selected, rotate it, and you can see that our monkey is like now attached to this as well. Issue with this, again, is making it a bit bigger. It's obviously not integrated with our scene at all. I mean, if we go to cycles, it's going to be a bit better. Let me actually get rid of this light. It's going to be a bit better because it's using this HDRI as a lighting for our monkey and all this. But again, the shadow catcher and all this, they're not there. And even if we were to just make this a shadow catcher already, I just want to really define the issue with this so people aren't like, oh, just click this button, you're done. The issue with just making this a shadow catcher is we want the ground information to be reflecting back on the monkey. And yes, it's in the HDRI, but it's kind of like infinitely off to the distance, right? We want it to be basically contacting this, okay? So kind of the normal workflow you'd use for this now, and this is where it starts to get a bit tricky, is you'd make a material for this. Let me change to GPU so we're not taking forever to load. We are going to import in the same image, so image texture, the same HDRI, we load it, you're going to see the projections wrong, and this is where most of the time you'd use something like windowed coordinates, right? Windowed coordinates just give us the coordinate system that our that is always like relative to where we're looking. But if we do it like this, you're going to see it doesn't work. If we do generated, it doesn't work. Normal, nope. UV, not a chance. Object, camera, window. Are you getting it now, Mr. Krabs? None of this is going to work, especially windowed. And this is because we don't already have an image predefined where we know where we're looking at it from. This is a 360-degree environment where we might at any moment, or we might even animate it, change the direction that we're looking, okay? The solution I figured out for this is I made a custom coordinate system. First, I'll describe how I made it, and then I'll show you how to like import it in, okay? The idea is no matter what, where this plane is, we want to project what is behind it, right? So if you were to hide it, we get our spherical environment. We want to project this ground that was behind it onto this plane. So again, anything behind it, you want to imagine rays are shooting from the camera through the plane into the environment. We then extract that texture and bring it back. Well, in theory, that means what we should be doing is we take this plane, we take its texture coordinates, whichever coordinate system we might want to use. I'm going to end up using like position coordinates. We project it to a sphere, and then when it's on a sphere, we just do a UV lookup. Because again, if you look at our world environment, which is where our sphere is, you can see this image is just using, I guess it's using generated coordinates. Although it seems like, no, I guess it's just using generated coordinates. Either way, we want to do a projection to a sphere and then do a generated coordinates lookup, I guess, right? Because if we project it to the sphere, then at this point, it's the same as this process, okay? The way we do this is you need a bunch of mathematical formulas for spherical coordinates, and then you need to project it to a sphere. I've made it easy, okay? Here's what you're going to do. Instead of using any of these coordinate systems, I've made a blend file. So I'm just going to click append. I've made two different node groups. I'm going to use world sphere because, again, we're using the world. If we instead put our environment on a sphere, use a sphere. So we're going to use world sphere. You import that in, and then you have that group. By the way, this is going to be available to patrons, and I know what you're thinking. Oh, I'm not a patron. What are the nodes? Here are the nodes. This is literally everything you need. So the idea is we take the position of this plane, we normalize it. Basically, this means every single one of these texture coordinates, in this case position coordinates, are then normalized. They're sent to the nearest like sphere point if you were to project from the center, because now these are all going to be unit vectors. So again, this operation, don't worry about it too much. It just means send it to a sphere. Then I do two tiny corrections just for the world shader. So I flip it, or I turn it 180 degrees and flip it. Don't worry about this. So again, it's on a sphere. And then the rest of this is basically spherical coordinate formula. So we have the x-axis is going to take arctangent, map range to change the range, and then all this, okay? I basically changed the coordinate system. You take this, you connect it, and you can see that it works. Again, here is all the nodes in case you want to copy them. This is going to be available on Patreon, and I'm going to make a exclusive tutorial explaining why it is these nodes particularly, but it's a bit, complicated for this. You can see now we have a plane that actually has the correct projection. Again, why did we do this? Because if we hide this, you can see we get the same thing behind it, but it's infinitely far away, right? There's no contact. This way, we actually have contact, and the projection works from the camera view, okay? It doesn't matter if we take the camera and rotate it, it will always work. It doesn't matter if we take the plane and move it, it will now just sample different areas from the camera's perspective, right? So it's going to look like the texture is changing, but from the camera, it will look fine, okay? So this is the secret ingredient. Well, now how do we kind of finish this up? Well, what you want to do is if you want it to be a shadow catcher, by the way, now it's a little hard to notice, but if we were to make this invisible and visible and all this, now that we're actually getting light information bouncing back up from the plane to the bottom of the monkey, this will be more visible when we add in a principled BSDF. So I'm just setting up a shadow catcher now. So you can see now we actually have our shadow. Nice thing about this is the shadows are generated from this HDRI, so the lighting is already directional and all this. I'm going to make the roughness 1, and I'm also going to add in a bit of bump. This is just so that when we look at the shadow, there's going to be a bit of inconsistencies with the ground, which is a good thing. So I'm just setting this up here. In other words, I'm just using this HDRI as bump information. It's a bit of a cheat, but we're basically turning this into a normal map. So again, this is what it looks like. We're viewing it here. And then finally, the last thing you need to do is with your plane selected, go to visibility, make it a shadow catcher, okay? So again, the advantage of doing this instead of just making it a normal shadow catcher is this way. So let me just get rid of everything we've done. Oh, stop with the phone. Stop with the phone. God. This way we actually get lighting information. So if this was just a white plane that we made a shadow catcher, this is what we get. But this is the version that actually has the projection. So you can see this is the after, before. It's a big difference. Just believe me. I mean, you don't need to believe me. You see it, okay? I'm mad because I tried to record this tutorial a bunch of times, but there you go. Also, a big plus of making this a physical ground instead of just this thing off to the distance is if you were to make a fancier material for this, like something that's metallic, reflective, transmissive, anything like this will actually work. So for example, I'm just going to smooth out this monkey, so I'm just adding some subsurf and shade smooth. If I was to make it transmissive and reflective, you can see it's actually kind of, what's the word, diffracting the light correctly. Again, if we didn't have this plane, it would look different. With the ground plane, we get the correct interactions. Additionally, if we, this is just me like doing a final lap showing this off. Additionally, if we were to make this metallic reflective, again, it works here. You remove the shadow catcher, not only does it get rid of the shadow, but the projection should be a bit off, especially where it's contacting. So this is a super important principle for how to do this. So you can kind of model any part of your environment this way, as long as you're using this shader. There is a bit of a caveat with when this projection is level with the XY plane, but you can see no matter what we do, it works. Just a couple other things just to really hammer the point home. Again, you can animate the camera. Even if you were to make this equi-rectangular, it all works. It actually moves with the camera orientation, right? It's in VR is the idea. A couple caveats or a couple things that kind of like further explain this. You can see, again, this is our coordinate system that I made. Again, you can make this custom. I'm not going to go over it here. But you can see this is what the coordinate system looks like. Let me turn off this shadow catcher so we can actually see it. This is basically the idea of taking the texture coordinates, projecting it to a sphere, and then doing a generated coordinate, I guess, lookup, which I thought was a UV lookup. The point is, if I was to go to the world shader now and look at the same coordinate system, you can see that these kind of line up together. This like seam lines up, right? However, if you were to instead do the exact same thing we've done before, but this time we're going to put our environment on a sphere. So I'm just making a big sphere that our camera is going to live inside. So let me just like reorient some of this so it's not as confusing. We have a sphere. I'll make it even bigger. Our plane, our camera, all of this is inside of it. You're going to notice that if we were to now, I'm going to make a material for this. This is just going to be our environment material. Image texture, connect this. We connect the HDRI. And we need to move it to update it, I guess. You are going to notice, I know it's taking me forever, I'm one-handed here, you remember this. You're going to notice that the ground is no longer lining up with the environment. And this is kind of an interesting point. Even though you'd think it's the same, we have a spherical environment around our camera, you're going to notice that it's kind of like inverted, right? So whereas we have, well, what am I trying to say? I'm trying to say that the coordinate system of the sphere isn't the exact same as the world shader. Which makes it so our ground doesn't actually line up the way we want it to. The correction for this is you use the other node group. Did I import it in? I did not. So I'm going to append it. Again, this comes with 2 node groups. It's going to be available on the Patreon, but I'll show you this one as well. This one is just called sphere windowed. So again, it's the windowed coordinate version of a spherical environment. Okay, you connect this, and now you see that it's correct. Let me just take off this principled BSDF so it's actually a bit faster. You can see that the ground is, again, matching to this. It's only going to work from the camera perspective, but now works with a sphere. It's basically the same thing as the other one, but then now there's no vector rotate in here or anything. Just so you see the full node group, here it is. But it's essentially the same thing. But you can see that the type of projection you use matters. So if we were to use the world, you can see it's a bit inconsistent, right? This isn't exactly lining up. You can see that here, especially with the door, but here it does. And then conversely, if we were to take the sphere and delete it, so now I'm looking at the environment, the world shader, right? Now we need to reverse it again. So any object that you want to be a projection, shadow catcher, whatever, in this case would have to be the world, okay? There you go. So you take this, let me make it principled again, just so it looks nice, shadow catcher. When it comes to adding objects in 360 VR, this is how you do it. You can add in animated things, you could change the materials, you could do whatever you want. You could animate the camera, literally whatever. But the headache is now over. At some point, I might do a tutorial about like tracking 360 degree footage, since I guess I'm obsessed with this now. But that makes it even more complicated, to be honest. But yeah, there you go, 360 degree workflow. I haven't seen this tutorial anywhere. Main takeaway, these nodes exist. It's available on Patreon and all this. That being said, what is this on the right? Is it a list of me saying 750 times in this tutorial? No. It's a list of patrons, okay? Patrons get access to a lot of stuff. They get early access to tutorials. They saw this a day or two early, so you can be part of that group. Additionally, they get blend files. Obviously, for this case, it would be very relevant because you get these node groups. Of course, you can make these yourself. I showed you the nodes. But you get the blend files just so it's easier on you. You could just append them. You get access to exclusive tutorials. Like at some point this week, I'm going to make a tutorial about why it is these nodes in particular that work. So that's just going to be a more in-depth thing. Discord access, stuff like this. Patreon's the place to be. There's a link in the description if you care. If you don't care, you would have already clicked away, okay? Patreon exists. Check it out if you care. Otherwise, thanks for watching the tutorial, you VR boys. I expect this video to be more popular in the future when people actually use 360 video. But for now, it is what it is, okay? So, whatever. I'm done. See ya.